Okay, so here we're going to look at the 2014 higher level paper, and we're going to look at question A3. So when we read through the question, we see that you're asked to draw a semi-parabola or two semi-parabolas. And again, these parabolas are going to be inscribed inside a rectangle. And we're also told that the lower part of the dish is a semi-ellipse. So part A here tells us that V1 and V2 are the vertices of the semi-parabola, and it is important to know what the vertex is, or the vertices in this case, and how they're going to be used. And then later on in the question we're told that P is a point on the semi-ellipse, and we have to draw small portions of two of the curves have already been drawn, so that's what we're told. So again, looking at the question, an overview of it, we're just using all of the principles that we would have learned in Junior Cert Technical Graphics. So we're putting a parabola inside a rectangle, and we're just drawing a ellipse, or in this case half. So the first thing that we're going to do, we're going to look at inscribing this parabola into the rectangle. So we can do it on the left and axial symmetry over to the right, or we can do it either way. So I'm going to start on the side where we've nothing done. So on the left hand side we have a rectangle. So all that I want to do is I want to divide the width of the rectangle here into 5. So this is a very easy way I found to divide, or to do line division. So I'm putting a dot every 10 millimeters. I'm going to draw all of these lines, and it's important to know that these are all parallel to the axis. So the vertex is always at the top or at the end of the axis. So I've just divided up that line. So next thing I'm going to do, I'm going to divide up the other width of the rectangle. So using the same principle, setting my set square up to 5, and every 10 millimeters I'm going to put a dot. So I'm not going to draw lines here, I'm just going to find those, and that's going to give me equal divisions on this side of the rectangle. As you can see, I'm not drawing lines. I'm going to see in a second why we're not drawing the lines. And again, it's good practice here just to label them. So I'm starting going away from the vertex 1, 2, 3, 4 and 5, and again working away from the vertex. That's 1, 2, 3, 4 and 5. So now I'm joining those up to the vertex, and every time 1 crosses the line 1 and 2 crosses the line 2, I have a point on the parabola. I'm going to join all of those up as carefully as I can and as accurately as I can. And there I have the parabola. And again, a couple of things to remember on the parabola: there's only going to be one vertex, and the eccentricity is equal to 1. Again, those are things that we do not need to know in this question. So I have one side of the parabola. I'm going to do axial symmetry and bring it over onto the right hand side. So with the parabolas done, we're going to move on to the ellipse. So when we look at the question, we're told, and we're actually shown, that we have a minor auxiliary circle and we have the major auxiliary circle. So straight away it makes our process much easier, because again, These are based on principles that we would have had from the Junior Cert Technical Graphics. So all that I'm going to do, I'm going to draw a line division here, and these lines, I'm dividing up the circles. So these lines can be drawn at any angle as long as it cuts the minor auxiliary circle and the major auxiliary circle. So I've drawn that line, and one of the key things we need to remember, when these lines hit the major auxiliary circle, they're going to go parallel to the minor axis, and when it hit the minor circle, it goes parallel to the major axis. So as you can see, that's another point off the ellipse. So here I've drawn another, just any angle line. So when it hits the major circle, parallel to the minor. When it hits the minor circle, parallel to the major. And I have another point on the ellipse. So I just need to do a couple of those. And again, the more points in the ellipse I'm going to have, the more accurate I can get this elliptical curve. Keeping my hand inside the curve, trying to join up the points, and of course I already have one which is the top or the end of the minor axis, which I'm just after meeting here. So I'm going to extend on the flat bottom. Just heavy in those lines. With the final step here, part B, we're asked to draw a tangent to the curve. So this is to the ellipse at point P. So when we're drawing a tangent to an ellipse, so it's going to look something like that where I have my set square, the first thing that we need to do is find the focal points. So the focal points will always be on the major axis, and the way we find it is we set our compass to half the major axis and we swing it from an end of the minor axis. That should give us our two focal points. So half the major axis and swing it from the end of a minor axis. So I'm just going to label this as focal point and focal point 1. So again, back to Junior Cert Tech Graphics, the way that we're going to draw a tangent is from the focal point. I'm going to join it up to point P and extend it on, and do the exact same from the other focal point. And what I have, I'm just highlighting these in green so it's going to be a little bit easier for you to see. What I've created is an angle here. So of course opposite angles are the same, and if I bisected this angle here, that would give me a normal. So I want to bisect the other one, which is going to give me a tangent. So again, to bisect an angle, set our compass to any distance at all. Swing an arc until it hits both ends of the angle. Keeping the compass the same, I'm going to swing an arc from those points. That gives me a point on the tangent. I already know that the tangent shall pass through point P. And that's question A3 complete.